Welcome to the first recitation. Long story short, this is more of a casual, interaction. So I'll probably be talking a lot about how things work and so on and so on. But if there are any questions at any moment, just scream them out, whatever you want, and we can work to answer those. So, quick introduction. My name is Max. I'm your TA for this class. Senior, right? Studying computer science and engineering. It's my last semester. I'm graduating, so decided to do this to try to get some extra experience. Hopefully, learn more about JavaScript by teaching you guys. I started coding in high school, right? Working with JavaScript, creating web pages, and I've been doing it ever since. My last summer internship, or for this summer, I was interning at Merck. I was building web apps for them, and the code that I wrote is currently in deployment and is saving them time and money. And I learned a lot during that summer, but I realized the importance of actually knowing the fundamentals from the very beginning. So that's why I'm here, and hopefully by the end of this semester, all of you guys will have a good understanding of how everything works and how you can actually use this to apply your knowledge for practical applications, specifically in web development. But the more you learn about JavaScript, the more you can use this to apply just software engineering principles in general, and perform well in life and in your job if you do decide to pursue a career in software engineering. So just a show of hands, how many of you have taken 216? Okay, this is good because 264 isn't an official prereq for 216, but it is still highly recommended. Okay, that's good. Excuse me. How many of you guys have actually used JavaScript before? Okay, great. So for the most part, I guess we're all on the same page in terms of almost everyone doesn't know much about the language. So that's why I'm here. All right, great. So I can operate with that assumption. The purpose of today's lecture or recitation is to essentially cover a problem that's similar to the homework, so you have a better understanding of what you need to know to solve the actual homework. And then moving on from that, I also want to resolve any questions that you may have from the lectures. Moving on to the actual homework, right? So your assignment is to essentially modify the array prototype to include an additional function which is similar to the map method, but with a little bit of extra functionality. So the way map works, and you can do this by essentially looking up the documentation. So all you have to do is look up JavaScript array or JS array map, right? And then you will get specifically documentation on how to use it, the syntax in terms of what arguments it's actually expecting, and some descriptions and some examples. So I highly recommend this for all of your needs in this class. This is essentially how you find out anything that you don't know about the language itself. So I won't be solving the problem of adding the function in question to the prototype, but I would like to go over how map works on a fundamental level. So I can do that over here. So sure, this is an online JavaScript interpreter, right? I can just run code here. Purely for my convenience, don't use this for your homeworks. You can use VS Code. There have been some posts in Piazza about how you can actually run the homeworks. There is no standard way of doing it. There are multiple ways. The suggested way of doing this was to essentially install the live server extension on VS Code and then use that to run your homeworks. You could also just go into your file directory or your Finder or File Explorer or whatever you want to call it, and so just open the index.html file, right? And then if you look at the actual code for that, then you see that it includes a link to the main.js script. So as soon as that web page loads, it'll run the actual file in which you actually make your contributions to, and then that's how you find out whether your code works or not. You can also, if you were to open up if you were to follow this route, right, and open up a web page, you can essentially just go on inspect element, and anything that you print in console will be printed here, right? Okay, moving on. Can someone tell me the basic principle of map? Yep. So for every element in the array, right, apply a certain method. And that method gets passed down as a parameter. So let's say you have an array, right? Can everyone see this okay or no? Awesome. Okay. So this is just an example array, right? It has 3 elements to it, 1, 2, and 3. So what map does is essentially take any function as a parameter, and this will basically have okay, where do I start? So this is a parameter, right? This can also be placed into a variable as well, right? Just to show you, like you can do this like in 20 different ways. Doesn't matter. So this is what's called an arrow function. I believe you guys covered this in lectures. Is that correct? Sweet. You can also do this essentially. So, right, you can use an arrow function, or you can use a standard, JavaScript function. For the purposes of this assignment, they're very similar, right? So I wouldn't worry about the nuances of anonymous and then this and that. So for both of these examples, right, lines 2 through 5, you can basically put anything you want to do to that element, right? As long as you return a result afterwards. So let's say I want to add 5 to each element in the array, right? So what you would do is return element plus 5, right? So removing this, you can pass this function, right, as a parameter into the map function, right? And what you will end up having, if I console this, is your result. So you see that you start off with 1, 2, and 3, and then you end up with 6, 7, and 8. This is the basic principle of map. I would like to move on to actually implementing a similar version of map to the array prototype. So if you go to any website, for that matter, let's see if I can make this bigger. So if I go to any console and console log array.prototype, you will see a bunch of methods, right? These are also available in the actual documentation of array, for example, in Mozilla Web Docs. You see them on the left-hand side over here. This is what you can basically use to, determine, to find the information that you need for all the functions that you use. So this is what you have over here. All right. The way we add a function, right, an additional function to this for your homework assignment is we essentially do anything along the lines of assigning a new parameter to an object, right? So let's say you just do test. And then you can do anything here, right? So what this small block of code does is it initializes a new parameter in the prototype called array, and then set it to an empty function at the moment, right? So if I were to do that, and then print it again, you would see this over here, right? So that's what we're going to do to start off here. In the actual map function, the only parameter that you are usually worried about is the single callback that is applied to every single element in the array, right? So if we are implementing a copy of the map function, we will just pass one parameter into this. And this can be named anything, just as long as you actually know what it is, right? Of course, follow standard naming conventions for variables so that, if another person is looking at your code, they actually understand what it represents. but as I'm sure all you guys know, like a variable can be named almost anything, right? So with this, we initialize a new function in the prototype called myMap. This myMap takes a single callback and right at the moment does nothing, right? Let's talk about how we want to access the actual array, right? Because right now you're currently doing array.prototype.mymap, right? And then the way you would actually access it is essentially, for example, you take any array. We already have R set to 1, 2, and 3, right? You would just do this. It's as simple as that, right? Of course, you would pass a callback into that, but at the moment, this does nothing. For purposes of demonstration, let me just run this, right? So whenever you call the function, it should console log hello. So if I run this, you see it over here. Okay. The way you actually access the elements inside of the array is through the keyword this. All right, so if I run that, you see hello, and then the actual elements of the array that we're calling. If I were to call myMap on anything else, right? Okay, sorry about that. So essentially, let's just set test2 to a new array, and then call myMap on that as well. You get a different result. So console log this essentially returns all the elements that we see here. So this is what you end up using to actually access all the elements. And then let's say we want to apply the callback to every element in the array, right? So you use a standard for loop for this, right? And then for purpose of demonstration, right, we loop through the entire array, and then we console log the singular element that's being accessed. So if we do that, we have a bunch of numbers that represent the two arrays that we apply this to. So I'm just console this out, and then the 1, 2, and 3 go away. Let's say you want to add, like 5, right, to all the elements in the array. How we do that in our new myMap function is to essentially apply the callback over here, right? So func is the function that adds 5 to any element and returns that element. So if I were to console log this, for example, then you see that it prints the original, right? So we have 42987, right? It prints the original, adds 5 to it, prints that as well. So you have this reflected in all of the elements in the array, right? But at the moment, this doesn't return anything. So if I assign this to a variable, or even not even that, let's just try to see if we can console this. This should return undefined because the function doesn't return anything, right? So that's what we see over here. That's not how we want our map function to work. So we should return something, right? So how we do that is you initialize an empty array. And then for every element in the original array, calculate the new result and then push it to the empty array that you have. And then you can return this. So right, and then just to make this neater, okay, so we access the original element, calculate the new one, basically use callback, which is a function, and then pass it to the original, and then push that new result to what we want to return. And then finally, we return what we want to. And then if we do that, you'll see that we essentially have a new array with a certain callback function applied to every element. Do you have any questions so far? Yep, so constant usually means a constant, right? But in JavaScript, that's not necessarily the case because everything is an object. So if we do, well, in this case, everything works because we're not actually overwriting the original array. We are using that array, which has a bunch of methods attached to it, right? So dot push. And then what that does, it modifies the original array without actually overwriting it. So in this case, I guess for the purposes of people who like aren't that comfortable with JavaScript, we can use let, and this will get the same result, achieve the same result, especially with var as well. So if I run this, we get the same thing, but just during runtime, right? It's best practice to follow a certain order in terms of convention, right? Whenever you assign a new variable, you want to use const as your primary target if you are not changing it, right? And then goes let, and then very rarely you use var, because var is deprecated. It has its certain behaviors in terms of like scoping, but anything that var can do, let can also do if you just implement like a workaround. So that's a good point, right? If I were to try to return const, for example, and then assign anything else to it, right? For example, you'll get an error because you're not allowed to assign a constant. If this was let, then this would go through. Of course, you have a different error because you cannot convert a Boolean to an array. But if I do this, then everything should run. So the good thing about JavaScript is, pros and cons, right? It's super dynamic. So you can actually, unlike Java or C or Go or Rust or any language that we covered in this or at Lehigh besides Python, I don't believe we covered any other dynamic languages, right? So unlike those, we can basically throw in a bunch of different types to a single variable. And then let's say in C, right, when you have a array, right, that array has to be filled with like a constant type. So all elements in that array have to be like a 1 or an int or a Boolean or a string or like a struct or whatever, right? This is a lot more flexible. So you can basically have right, you can have a bunch of different types in one array, and this would be completely valid. Okay. Does everyone have a good understanding of when and when not to use const and why this works in terms of adding elements to the array without actually overwriting the original reference environment for that? Okay. All right, here's what, if things aren't confusing already, here's where things get a little bit worse, because the original map accepts callbacks that have more than one parameter. So this is what was referenced in the actual assignment, right? So over here you have X, Y, and Z, and this remains true for map regardless of the names of the variables, right? So like X basically stands for the current element, right? A good way to name that would be current or element or whatever, right? The second one is the value of the current index, like 1, 2, 3, or 4. And then Z is a reference to the original array. So how that reflects in our code over here is essentially we have the element, right, the index, and then the actual array. This is something that you do have to worry about in this assignment. For the purposes of understanding everything, let's do something interesting. So if you look at the documentation for map, right, the callback function accepts element, index, and array, right? This order remains constant. So if we do that, if we want to implement a copy of map, then we have to do the same thing. And you also have to do this for your assignment as well. So in the callback, we have to accept these parameters as well. This is pretty simple, right? Because look at it this way. You already have a variable holding the index, which is I over here, right? So you loop through the entire array by having I, looping through I, and then accessing the original element. So if you want to pass the index into the callback, you already have it over here, right? And then if you want to pass the original actual variable, right, then you can do that here as well. Or actually, no, that's a lie. This. Right. So by doing this, we essentially make our new MyMap function compatible with these three parameters, which line up with how map works. So if I run this code, you'll see a bunch of console statements. And let's see. With our test case of our small array here, right, we loop through every element, and then we do three things. We console log the index, so that's what you see with 0, 1, 2, 3, and 4 over here, right, because we have 5 elements. So for each time we loop, we have to apply the callback, and then what the callback does is it prints these statements. So we console log the index, we console log the original array, which is why you have a bunch of copies, right, or not copies, but like these are, you're basically printing out the original array. And the original array doesn't actually change, that's why this remains the same, right? So the purpose of map is to create a copy of the original array with the callback applied to every element available. So we do those two things and we return element plus 5. Okay. So by doing this, we essentially made a copy of map, right? So this is how map works. We just created a new function, added it to the prototype by doing this, and then duplicated or replicated the functionality that's already provided by core JavaScript. Your assignment builds off of this, but it makes things a little bit more complex. So instead of accepting one callback, you accept a indefinite, or I mean, it could be an infinite amount of parameters, and then for each element, you roll a dice, and then randomly select any one of those callbacks and apply it to just that element. So let's say if you have 8 elements, or let's say it doesn't matter how many elements you have. If you have 8 callbacks in your homework assignment, right? Then for each element, there's a 1 over 8 chance of that specific callback being applied to each element in the array. So there was a Piazza post about how this is done. Does anyone know how to accept the multiple parameters without doing like X, Y, Z, because like this results in a fixed number of parameters. How do you make this so that it accepts in like just something that you can loop through? Does anyone know? Sweet. Okay, so the syntax for that would be the spread operator, right? So what this does, it essentially assigns X to all the parameters, right, that you can actually use, and then spreads it out so that you can actually access it. So the way you would do that, let's just change something. And then let me just create a new function for this. Right. So essentially, I'm keeping this code untouched, right? So this is the original like duplicated map code, and I just create a copy of that, change up the name, and then instead of accepting one parameter, I accept an indefinite amount of parameters. So how you access each one is you can use a for loop, right? So with this new function, this wouldn't work, right? Because it's a singular callback. So this is undefined currently. But what we can do is loop through all of them, right? And you can do this in multiple ways. The most straightforward one would be this, right? And if you want to learn more about how the syntax works, you can always look up the way it works in Mozilla documentation, right? And then so what for of does is basically it's a statement, right? It runs a loop by taking any iterable, and then instead of the traditional for like let I equals to 0, instead of looping through I, right, you skip that part and just actually put the original or each element of the original array into a variable, and then you can access it from there. So that's what we did here. But you can also just follow the standard route. So like if you're uncomfortable with this, which I suggest if you are, you can practice with it. but you can also do this. This works just as well for this assignment. So I'll return to this, but let me just demonstrate something else for you real quick. So with this function, right, all of these are meant to be callbacks, which are functions in of themselves. So you create a function, and then as parameters, you accept more functions into those. And then, right, so you basically end up having like this nested stuff. And it might be hard to understand, but let me just simplify it down to how this works. Right, so I just created a new function here, right, arrow function. I'm using the spread operator, so param stands for all the parameters that are passed to this function, and then what we can do is access each one, and then console. All right, so regardless of what I pass to this function, all right, let's say I want to pass numbers, strings, booleans, right? What's going to end up happening is, if you look at the console, right, all the parameters that we passed are, accessed by this variable and then printed to console. So the same thing applies to functions, right? Functions as parameters. So returning back to this code, this is exactly what we do here, right? And then let's delete this. Okay. All right, so if we apply the same concept to our new multi-call function in the prototype, at the moment we're passing only one, right, callback. So if we do that, essentially, let's make this less complex. Right, so what we do here is, first we loop through all of the elements in the array, right? And then for each element, we loop through all of the callbacks that we have access to, and then apply it just to print it to console. Okay. At the moment, we don't push anything to our holder, like to return. So when we console log the result of the function, it'll just return an empty array. If this already has stuff in it, then it'll just print that instead, right? So let's make this a bit more interesting by having multiple of these callbacks. All right, so we introduced two more potential functions that we want to apply to all of the numbers, or all the elements in the array. So the first one is the same one, right? Add 5 to the element and then return it. The second one is multiply by 2, and then the third one is overwrite the entire thing with a string called hello. Okay. So if we were to pass these two to our function here, we would essentially see the following, right? So keep in mind the differentiating console, right? This is basically just dash line, so that you can visualize how everything works for each element in the array. So for the first element, right, then the original number is 4, right? And the first callback is to add 5 to it. We have 9 over here, right? The second callback is to multiply by 2. That's why we have 8. And the third one just replace the whole thing with hello. So again, we don't add anything to return because this is just for demonstration purposes. But let's say you want to push all three of these new results to the array. And then we also want to know, I'll just do it first and then y'all can follow along. All right, so what I just did is for every element, right, I created a empty array. And for every element, I want to take all the callbacks and put the new results into that, right? And then finally, I'll push that to the final result. So if I run this, we'll essentially have an array with 5 elements with 3 elements individually, right? 5 elements representing the 5 original elements that we had, and then each one is an array containing 3 elements representing the 3 callbacks that we had. So we basically have like a for loop nested in another for loop, and then we go through the processes of determining the callback, right, through our spread operator. So we put that in the variable, and then we can use that as a function, calculate the new number, and then push it to the new num array, which in this case, for example, for the first element, it's just like an empty array here. And then as we push stuff to it, it populates with our result. So that happens with our array, and then we push that to the final result, and then we end up getting this. Any questions so far? Yep. Would you Oh, you could. So for better or for worse, right? Everything in JavaScript, there are like 5 different ways of doing. The first way is to use a spread operator with callbacks. You can also use the arguments. So let's see if this works. Right, this results in the same thing. Arguably simpler, but I guess you can even replace callbacks entirely with this. Yep. It's really up to you. So there are multiple ways of doing it. We're not looking for a specific way in your programming assignment. We just want you to demonstrate a general understanding of how JavaScript behaves, and then you can implement this. So this is most of your homework assignment, right? What I leave up to you is to essentially implement the random selection, right? So you already have your index, for example, right? In this case, this loops through all of the arguments. Instead of looping through all of them, you select a random one, apply it, and then that'll be your assignment.